I thought we were done filming on the hood for the 49 Willys, but there's one more thing I want to show you guys. Stick around. We thought we were done, but we have a little thing, a little inner lip, if you will, that's folded around that we've had to remove to be able to fix all of this sheet metal damage. Something I thought, and we had some requests on, was edges of doors when you are gapping a panel and you are welding the edge, how it will shrink inward. And then when you metal finish it, what are some of the pros and cons? Well, it's not a door, it's a hood, but it's the same exact concept. We have taken this 1/2-inch strip, made it exactly the same as the inside, and what we're going to do today is we are going to place this on the inside and weld it. And we're going to show and talk about the different ways you could weld it, the pros and cons to welding it those ways, and then how we fix it. Because what it's going to do, it's going to warp the hood. Something you need to take into consideration is having the hood done and having it metal finished before you weld in a patch panel, because if you do weld in a patch panel and you have warpage already there, as soon as you heat it up and start taking the weld to it, it will actually take off more in those areas, and then you're not going to know where you actually need to hammer and dolly to bring it right back to that mirror. That's the whole reason you want it relaxed state. Everything should lay in nice and flat, and then we'll be able to clamp this. We're going to flip this hood over, and then we'll show you how we start this process. We have our 1/2-inch panel, and if you come in here, you can see the lip that we've removed. We had to remove this lip because when you're hammer and dolling this edge, trying to get it nice and flat, this edge would hold you up. I talk often about in the previous videos, when you are metal finishing something, it cannot have anything on the back side. It needs to be completely clean. So if you even had so much as a burr or a piece of undercoating and you were trying to hammer and dolly that, it is going to take the shape of that part. So we removed this small section in the center on top of all of the structure. Now, when you're taking this piece, we sheared this thing off so that way it's completely square all the way across and looks exactly factory like the lip did. Instead of drilling this with a drill, because if you were trying to drill this, especially with a small 1/2-inch wide piece, it would just have all kinds of warpage to it. This is a small flanging tool. It's air pneumatic. It does two different things. It flanges on one side if you need that option. For this particular instance, we only use the other side, which pops a very small hole, and it allows, when it pops it, to keep it from warping. It doesn't just push the center, it holds everything nice and straight as it shears that hole into the center. The other thing you need to take into consideration is making sure everything is completely clean. So we're using stripper discs on just a little 3-inch roll-lock and a die grinder. We've cleaned up this edge, we've cleaned up the hood edge. It's even more crucial with a TIG welder that everything is super clean versus like a MIG welder. We're going to place this piece in, line it up, and cut this side last so that way it fits right into the seam piece. We're going to use small vice grips, and we're going to clamp this very close. And as we weld this together, we're going to be using air to try to keep our weld from shrinking down, right? We've talked about in previous videos that when you weld, the weld grows and then it shrinks. So part of the reason that we're doing this video is understanding what is going to happen before we actually take action and weld it. When we weld this, what the hood's going to do is it's going to shrink. And because the curvature is going this direction, it's actually going to shrink in. It's going to create almost like a turtle shell. And if you have any areas that are not perfect with the panel, depending on the damage of the panel, it's going to take off and warp or oil can. So if you know the hood is good before you weld it, and then you come in and you get it all tacked in, and we're going to keep in mind we need to tack weld this piece about every 1/2 inch to 3/4 of an inch away from each other. And then when we actually weld it, we'll probably come in and we will weld the plug holes first, so that way it holds it down. We will still keep clamps on it as we go, and the goal is we're going to continuously weld from one end to the other. what that's going to do, some guys like to do it in stitch welding, but here's the problem with stitch welding. There's pros and cons, and let's talk about whether you're MIG welding it or whether you're TIG welding it. If you are going to MIG weld this, stitch welding isn't necessarily a bad option. But some of the things you need to know is that MIG welding is very brittle. We've talked about that in previous videos too. But when you are hammer and dolling this, so this panel is going to shrink after we weld, and then we're going to have to hammer and dolly this and stretch it back out so it will lay back down flat. Same concept for a door edge. If you're welding that, it's going to kick in and we have to stretch that back down and out flush. So you could use a straight edge. Maybe you just shear off a piece of metal to check flatness from the outside after you weld it. Like right now, you can see this thing's sitting perfectly flat, and after we weld it, we'll stick a straight edge back on it, and what you're gonna see is that it dives down, it dives up. Once we get welding it, if you're MIG welding it and you start grinding the edge so it looks like the factory edge, clean, you're not left with enough weld. And when you start hammer and dolling it, a lot of times, if you can't see it, it's super close to cracking. It's super thin, it doesn't have the penetration that you're gonna get with a TIG welder. That is the super big advantage of TIG welding, is the heat concentration is going to be far less than a MIG welder. The other thing you can do with a TIG welder is you can weld it continuously from one end to the other without stitch welding it, and what it's going to do is it's going to take that warp, and yes, it's going to take a little bit of warpage and go all the way through. Depending on how good you are at welding, whether it be MIG or TIG, is how much warpage you're going to have. Some of the things that you can do to eliminate excessive warpage if you are MIG welding is to have an air hose on hand with a blowgun that you can do, whether it be tacks or whether you're welding a ½ inch at a time and cooling it as you go. That way the whole heat doesn't just take off and warp everything completely. You're trying to keep it to a minimal amount of warpage. So being proficient at TIG welding and setting up your TIG welder properly is kind of key. We have our TIG torch with, I'm using a 16th. You can use 3/32, it's not a huge deal, but we're trying to concentrate the heat as little as possible. We are using a gas lens to try to keep the gas coverage in our area where we need it. You don't have to have it, it's just an added layer of protection. The other thing you want to do is match your filler rod with the same thickness of the hood. This hood's about 43 thousandths, so we matched our wire to the thickness of the gauge. And we are going to set up our TIG welder. We just started trying out the different pulse techniques, so that way you're eliminating so much heat diving into the hood. With a pulse technique, you can fluctuate your pedal and your amperage to be able to work that all the way through, and the pulsing is keeping the excessive heat from being in there all the time. And you just have to learn that setting and play with your TIG welder till you get it where you like it. Everybody TIG welds very differently, and we're even experimenting all the time to see what works best. So you're going to tack weld everything ½ inch to 3/4 inch apart, so that way nothing can take off. If you were to start welding at one end without this thing tack welded in, maybe you just had it clamped. Even with the clamps, the metal will start to take off and it will start to separate. And when it does that, then you have excessive gaps. TIG welding wants no gap. If you can eliminate a gap altogether, that's ideal. And you're trying to have, the other advantage to it is when you are taking your die grinder and say you have an 80 grit sanding disc on here, the amount of weld that you're left versus a MIG weld is so minimal, and it has better penetration, that it's faster to clean up the edge and you're going to have a more consistent bead. After we weld this entire piece in and it curls, what is the whole reason we're making this video? Well, the number one thing that I go to car shows and I look at is the door edge to a car. You know from looking at a door edge whether they have done this technique or whether they haven't. You're trying to eliminate how much body filler. We've already spent all this time, roughly 50 hours in this hood metal finishing to get little to no body filler, right? So the more you take the time to make this perfect, the less body filler you're going to have to use. This is all part of the body working stage, and if you did not do this process with hammer and dolly to stretch the edge back, you're left with a thick edge. So you're gonna have, maybe your hood's in really good shape, but it's deceiving because you go and look at the car at the end and what you're left with is a 1/4 inch door edge full of filler. And let's say you shut the seatbelt in the door or something ironic that gets hit on the edge of the door, it's going to chip out way easier than if it was just nice and thin like the factory and straight. That's the whole purpose of this, is to make sure that the quality of your paint job at the end doesn't reflect something that would tell somebody, oh yeah, they got a lot of body filler in the car. The whole goal is every car uses a percentage of body filler. Even some of the best in the world that I've seen with coach smithing and metal shaping, the amount of body filler at the very end from panel to panel. So maybe this hood is perfect, but when you're doing a transition from a hood to the cowl or a door to a fender or quarter panel, you're still going to have a level of body filler that you skim coat with the car. The whole goal is a good foundation, not excessive. Everybody uses body filler. I'm admitting that. However, you want to try to eliminate as much as you can to provide no cracking and future problems. I just wanted to show the spacing of the tack welds so you guys understand how close they should be so they don't start separating between when you weld it. And if you guys don't know, we talked about stitch welding, what that is. That would be where whether you MIG weld or TIG weld, whether you would weld maybe an inch or so at a time, 3/4 of an inch, and then jump over here and weld this, and jump over here and weld this. And you're trying, the thought behind it is you're keeping your heat down and you're cooling it in between sections. But if you can weld proficiently and weld from one end to the other, maybe you might have to stop in a few areas, but the whole goal is you're trying to keep the same amount of heat and weld in the edge of the panel all the way through. And what it does is it warps evenly and works it all the way through from one side to the other. There's nothing wrong as long as you know how to correct it, right? We understand what's going to happen. If you stitch weld something and you cool it, you're adding a different amount of heat here versus here, and it's not as consistent. So you're going to get a little bit more of a warpage. Doesn't matter whether you TIG or whether you MIG, you're going to get some level of warpage. How you fix it with a hammer and dolly at the end of this when we show you is really what matters. So we're going to start from one end and we're going to do our best to get all the way from one side to the other. We'll probably have a few sections we're going to have to stop. So here we go. Now that we have completely welded it, we have faced the weld with the grinder. We used the Rolock with an 80 grit disc. And what you want to do is just hold this thing at an ever so slight angle to where you're just facing the weld. You're not trying to remove a ton of metal across the 1/2 inch strip. That way, as we hammer and dolly this back flat, it will start to even out and we can grind it completely smooth with a DA at the end and it looks like we never welded it. Showing the straight edge, we can see the amount of shrinkage that we've had from the weld, and as long as everything else is where it should be before we welded it, we know we can just come back and hammer and dolly this edge. Now, when you're selecting the hammer that you're going to use, this is a linear stretching hammer. It is not your typical round face. And if you think about this as this edge is water, what is it going to do if you struck it with a hammer? If you struck it with a round hammer, the water is going to displace in 360 degrees and it's going to stretch. We know that the edge is shrunk, we need to re-stretch it back out. Going back to basics. If you use a linear stretching hammer, it is stretching only linearly. We have a rectangular head with a rounded edge and it has a high crown. So when I strike this, if you pretended that it was water, the metal is going to disperse in this direction and in that direction, and it's going to stretch it back down. So we're going to use a flat toe dolly on the backside. We've already verified with our straight edge that we need to take, so if this was a door, you could take the door off the vehicle, lay it down, Or you could do this on the vehicle. It's going to be a lot harder, especially if you're just checking with a straight edge. But it's nice to be able to put the door in a relaxed area, be comfortable, put your toe dolly down, and you're going to linearly stretch this edge back out across the way, doing it slowly as you go and checking it. You don't want to overstretch it, because if you overstretch it and you hammer it too much, now it's going to start going the opposite direction and you will have a low in between the edge and where you've metal finished. The goal is to get it right back dead flat. So that's what we're going to do now. Just slowly hammer on dolly and work this edge back down flat, stretching the edge. And then we will check it. You can already see it is getting better. The other thing that you want to remember is that if your edge is not completely metal finished and you still need some grinding, you might want to come through this and do a couple passes to get it closer, and then you can come back in with your 80 grit and or a DA and you can finish taking that weld completely out. If the weld at the edge is a slightly thicker than the sheet metal, no matter how much you hammer and dolly that, because it's thicker on the outside, it's not going to smash down exactly flat. The goal is you're taking a curve and you're slowly working it back down, and then you get it metal finished more, you get the weld hammered and dollied up. So even if we've talked about it in the other videos, done a weld in the center of a hood, you got to hammer and dolly it back up. It's the same principle, basics. That's how you get the edge stretched back out. And we showed the quick little clips at the end how if you do overstretch it and it goes the other direction, you just grab the shrinking disc, give it a few rubs, use a block and find out where it's high, rub that area that's high, bring it back down, and level the playing field across the whole edge. One thing you guys need to keep in mind, the pros and cons really affect that edge. If you had MIG welded that, it's such a hard weld that by the time you got done grinding it and finishing it, and then you hammered and dollied it that much, it for sure, without a doubt, would crack. So there is definite advantages to having the TIG welder. It's just a lot more maybe time and prep, but it takes way less time to grind it down too. So hope you guys enjoyed this part 3 of the Willys hood. We're gonna give it back to the builder, and it'll come back for body and paint, and we'll continue this whole process on another video. Till next time, guys, thanks for watching.